now we're going to start adding these functions together. Now, it's not like we haven't started adding some of these already, subtracting them, multiplying, and dividing them. But now we're going to be asking you questions like, how does that affect the domain when you start taking things that you know and putting them together in different ways? Now, one of the side notes that we need, I shouldn't say side notes, but one of the things, basic things that you need to focus your attention on are fractions. What do you know about the denominator of every fraction? What do you know about the denominator of every fraction? Okay, take 20 seconds and figure out what you know about denominators. Okay, talk to the people around you. Okay, what'd you figure out? The denominator cannot equal 0. Okay? Maybe I should write that DEN. Denominator not equal 0. What do you know about the part under a square root? I believe they call it the radicand. In case you're wondering at parties or if you see it in television commercials or billboards or movies. What do you know about the radicand? I believe this is called the radicand. I never used the term radicand. What do you know about that thing? Okay. It can't be what? Can't be negative. Let me explain what can't be negative means. Greater than or equal to 0. That's exactly what you said. Just in mathematical lingo, or language lingo. So that was weird. I don't think, but you know, we might get into logarithms. What do you know about the argument of a logarithm? Oops, sorry. What do you know about the argument of a logarithm? Any numbers you can't plug in, please tell me we know what a logarithm looks like. That was in section 1.3, one of the basic, one of the 9 functions we were working with. You know, remember the picture? Come on, what do you know about it? What kind of numbers can you stick in there? Any numbers? No, that's not true. The graph says so right there. Positive numbers? Okay, I'll interpret what he said. Greater than 0. Alright? So 1 can't equal 0. 1 is greater than or equal to 0. And 1 is just plain old greater than 0. Those are important facts that you need to remember. Go back. Going back. Way back. I mean, those 3 facts are extremely important to you. Got them? Okay, we'll make like movie theater credits. Alright, now, in example 1, we've got 2 functions, and we are being asked to combine them. By the way, you'll have to do 2 through 8 evens tonight. Please make sure you do them. Okay, 2 through 8 evens. That's not a whole lot, is it? 2 through, what do you think I said? 2 through 80 evens? They'd have to be real easy questions for me to assign that many. Okay? No, 2 through 8 evens. Yeah, they'll be like 2 through 8 all. Oh my goodness. Okay. 2 through 8 evens. Okay. Now, 1, 4. Yep. So let's start out with just adding. Okay, we're gonna try to go through this quickly, and I hope I can get through this one example with you. Now, if you're just adding those two functions together, f of x and g of x. Okay, and by the way, for those of you who see this notation, and if you think that's the distributive property, you're kind of right. But it's more like this. Okay, that's really what they're asking you to do. Now, so that's x squared plus the square root of x plus 1. You know what x squared looks like? Right. So we got the product, right? Do you know what the square root of x looks like? Positive square root of x. Right? What is that plus 1 doing inside there? Shifting which way? Left or right? Okay. Left 1 unit. So what the heck's going to happen if I put those two things together with addition? Rapid. We got the graphing calculator, folks. You start combining these things with weird, you're like, I don't know what that's going to do. Neither do I. Let's grab that. Let's look at it. Because it's not, you think you're going to be able to guess, but I don't know. So graph it. Let's see what happens. Okay. Okay, did you get something that looked like this? Looks like part of a parabola, kind of. What's the domain of that? Because that's what it says. Find the domain. Okay, I've got a vote for -1 to infinity. Do we include the -1 or not? How do you know? Ah, that's a good answer. I like it. All right. Go take your calculator, hit the trace button, type -1. If it gives you a y value, which is what she just suggested, then we know it's included. But if it's completely blank, then you know it's not included. And it should give you an answer, right? So we know it's included. That's a good, I like that. Okay? So, what happens when we go to the next one? Subtraction. Do you know what that's going to look like? No. Graph it on the calculator. Neither do I. So, it's probably going to look similar to the last one. It's lower, isn't it? It does look like it goes above the x-axis on the left side too, though. Okay. What's the domain? Just because it's lower, that may or may not have changed the domain. What's the domain? It is. Does it include or not include? It includes. Oh, by the way, for those of you wondering where this magic -1 is coming from, what do you know about x plus 1? What do you know? Remember, it's a radicand. It's that part under the radical. So what do we know about all the parts under a radical? Did you say positive and negative answers? I thought we just got done discussing this. Greater than or equal to 0. So, if it's greater than or equal to 0, solve that for x. Greater than or equal to -1. Hey, look, it matches. Alright, so what happens when we multiply these things together? What do we get? Something like that. What's your domain? What's your domain? Is it still the same? Yes? Okay. How about f divided by g of x? Name a company that would be extremely proud of this particular graph. Name a company that would be extremely proud of this graph. Nike, you got it. Nice job there. Well, see, this one kind of does something. It looks very Nike-like. It does so. Look at it, man. What's the domain? Oh, but is it the same? Well, you hit the trace button and type -1. Why is it not there? Why is it not there? Okay, there's something good that you're thinking about. Not only do we have a radical, you get a denominator. So, what? Correct. It's the denominator issue. So we not only had the radical, but now we have that denominator issue, which means you lost the closed bracket. Yes, I'll expand it out. Okay? 2 through 8 evens, or in some of you have to do 2 through 80 evens, but the rest of you do 2 through 8 evens, okay?